In this video, our focus is going to be on particle size distribution. The word itself is simply referring to the distribution of particle size. Now, in mineral processing, particle size distribution is a representation of the distribution of particles in a particular stream. It could be flotation feed stream, it could be final tail stream, it could be hydrocyclone underflow stream, or whatever it is. We are concerned about the particle size distribution in that stream. Particle size distribution is a factor, is an indicator of performance of grinding circuit or the classification operations like the screening operation or the hydrocyclone performance. Determining the correct representation of particle size in a stream is vital in all mineral processing operations. In this video, our focus is on two different models that are commonly used to represent particle size distribution in a stream. One is the Gaudin-Schumann distribution model and the Rosin-Rammler distribution model. Now, in this particular example, we have the raw data here. This setup is an Excel template where you will just enter your raw data and it will calculate everything for you. So now, to determine which type of model best describes the raw data, we look at two criteria. One is the R-square value. The higher the R-square value, the better the model explains your raw data. And the second criteria is the mean squared error. The lower the mean squared error, the better the model fits or explains the raw data. Now, in this particular example, the R-squared value for Gaudin-Schumann is about 0.76. That means only about 76% of the data can be explained by the Gaudin-Schumann model. Looking at the R-squared value of the Rosin-Rammler, it's about 0.89. So essentially, that's around 89% of the particle size distribution can be explained by the Rosin-Rammler model. Looking at the mean squared error values, the Rosin-Rammler has a lower mean squared error value, so it is a better fit to the raw data. So based on these two criteria, the particle size model that best describes this raw data is the Rosin-Rammler, because it has a higher R-squared value and a lower mean squared error value. Now, I will put in some other raw data in just to show you how this template works. So this is where you enter the raw data. I'll just paste in different data. So this is the output. It's all set up and calculated. You don't have to do much. Yes, so also in this example, the correct particle size distribution model is the Rosin-Rammler model, because it has a higher R-squared value and a lower mean squared error value.